The Data Conservancy are developing technologies which integrate the packaging, archiving, and access of research data. These technologies use existing standards such as the IETF Bagot Draft and implement linked data principles. The work done by the Data Conservancy builds on existing technology platforms such as the Fedora repository and the Open Science Framework. This screencast demonstrates three discrete technologies that, when used together, present a workflow for data to be curated, packaged, archived, and presented to end users. The packaging tool is an interactive desktop tool which is used to author rich descriptions of the data and produces a package that contains both the binary data along with the semantic markup. The Fedora package ingest extension leverages the Fedora API extensions architecture and ingests the contents of the package into Fedora as linked data resources. Finally, the Fedora OSF storage provider allows users of the OSF to connect to a Fedora repository and browse the contents of ingested packages. In my browser, I've prepared some tabs containing a dataset and metadata to be packaged. These data are from NOAA and record liquid precipitation from over 2,400 weather stations across the United States dating back to the 1970s. I've gone ahead and downloaded the data to my hard drive in preparation for packaging. Note that I've made some choices regarding the organization of the data. The data itself is organized in a hierarchical structure, with the documentation for the data sitting off to the side. We will revisit this structure in a couple of different ways as we proceed with the demonstration. We'll begin by opening the Data Conservancy Packaging Tool and creating a new package. The Packaging Tool prompts the user to enter in some required metadata with additional fields for recommended and optional data. I'm simply copying and pasting the metadata into the Packaging Tool from the online documentation for the precipitation dataset. Audience members familiar with the Bagot specification will find these metadata fields familiar. They will be serialized as Bagot metadata when the package is generated. After entering in our metadata for the package, the Packaging Tool prompts us to add content to the package. I'll navigate to the directory on my local hard drive that contains the data to be packaged. After adding content, the tool presents a hierarchy of resources which mimics the hierarchy of files on disk. Note the highlighted resources indicate hidden files which by default will not be included in our package. We can remove the visual clutter by deselecting the Show Ignored Nodes checkbox. Likewise, if we wish to reveal exactly where the package resources exist on disk, we can toggle the Full Resource Paths control. Let's spend a moment discussing the Types column. Internally, the Packaging Tool has created an instance of a data model according to the content being packaged. Each file and directory to be packaged is represented by a node in the model. The Packaging Tool has assigned a type to each node based on the structure of the data on disk. The user has the opportunity to review the types assigned by the tool to the package content, modifying the assigned type as they see fit. The allowed types and properties of those types are governed by the Data Conservancy business object model, which is heavily influenced by the earth science community. Here I am modifying the type of the documentation resource from data file to collection metadata because the contents of this resource describe the data in the top level collection. Each resource in the package has properties that may be set by the user. The properties vary by the type of resource. Here I am going to set properties on the top level collection, copying and pasting the metadata from the online documentation for the dataset. To save time, I'm going to select these properties for inheritance. Each resource underneath this collection will receive the values I've applied at the top level. If I were curating this data in reality, I might use more discretion when applying the inheritance features of the tool. After adding metadata and manipulating package resource types to our liking, it is time to generate the package itself. The package generation screen presents different options for choosing the format of the package and the serialization used for the semantic information contained within the package. After selecting an output directory, the package will be generated according to our selected parameters. Now that we have generated a package containing binary data and rich semantic markup, we will ingest the resources in the package into Fedora using the Data Conservancy Package Ingest extension. This ingest process will represent each resource found in the bag as a web resource within Fedora. I have an instance of Fedora up and running and have created a new empty container named precip where the package resources will be ingested. This instance of Fedora is configured with the API Extensions Architecture, or APIX for short. APIX binds HTTP services to Fedora resources, enabling the package ingest service to be discovered by clients using linked data principles. Performing a head request on the precipitation container returns HTTP headers describing the characteristics of the container. Included in the headers is a link header with a relationship type of service. Dereferencing the service link header will return a service discovery document for the precipitation container as an OAI-ORE resource map. I navigate the service discovery document for the resource representing the package ingest service, keying on the isServiceInstanceOf property. Once found, I can look for the value of the hasEndpoint property, which will be the URL for the package ingest service itself. Navigating link headers and understanding the semantics of the service document allows me to discover the URL for ingesting a package into the precipitation container. With the ingest service URL in hand, I'll go ahead and use curl to post the package to the service endpoint. The ingest service will emit events as resources in the package are deposited into Fedora. A key aspect of this ingest service is that it preserves the relationships present in the package. URIs of individual resources within the package are remapped to public URIs in the Fedora server's namespace. After the ingest is complete, I'll go back to the Fedora UI and refresh the empty precipitation container that I created earlier. You'll see that a single resource representing the top-level collection of the package has been created. The files representing the collection metadata are present, just as we specified in the packaging tool. Recall that a number of properties of the top-level collection were also specified. These properties are also present and accounted for. The package ingest service has maintained the relationships in the original package. We are able to navigate between the resources by simply clicking on the links. Thus far, we've used the packaging tool to create a package containing rich semantic metadata and have ingested the resources into Fedora as linked data. The package ingest service deposits each resource from the package as a resource in Fedora and maintains the links between resources, remapping package URIs to Fedora URIs. APIX allowed us to inspect the precipitation container and discover the URL to use for ingest. Now we can connect users of the Open Science Framework with the newly ingested data in Fedora using the Fedora OSF storage provider. I've already logged into the OSF and have pre-configured the Fedora storage provider to talk to my Fedora instance containing the precipitation dataset. Because the Fedora storage provider is under active development, I'm using a development version of the OSF platform for this demonstration. I've created an OSF project for the precipitation dataset. I've not filled in any of the aspects of the project, choosing to leave it empty so we can focus solely on the functionality offered by the storage provider. The storage provider allows you to mount any container in your Fedora repository. I've configured the storage provider to mount the precipitation container, so we won't see any of the other information in the repository. By now, the structure of the data and the files may be familiar. We are browsing the contents of the Fedora repository, and so we see the documentation for the data at the top level of the hierarchy. Let's open one of the files to satisfy that we can not only browse the structure of the repository content, but also download data. The Data Conservancy has produced tools that integrate with popular platforms which facilitate data curation, archiving, and access. The Data Conservancy Packaging Tool provides a mechanism for curating and packaging data. The package ingest service is able to ingest these packages into the Fedora repository, and the Fedora OSF storage provider connects to Fedora, enabling collaboration and access to the data.